dear, welcome to our tutorial classes of class 11 physics of Manas Academy. In last lecture we read the formula of the combination NCR, that is equal to factorial n upon factorial r into factorial n minus r. Okay, now today we will discuss about binomial theorem. And to know about binomial theorem, at first we solve some questions on the formula of NCR is equal to factorial n upon factorial r into factorial n minus r. Uh, some at first NC0, what will be the value of NC0? Then applying the formula of combination, NC0 will becomes factorial n upon factorial 0 into factorial n minus 0. That is equal to factorial n upon factorial 0. You read in previous class factorial 0, the value of factorial 0 is 1. So put the value of factorial 0 is 1. Factorial n minus 0, that becomes n, cancel out factorial n, then the value comes nc0 is 1. It's like saying nc1. What will be the value of nc1? Applying formula of combination factorial n upon factorial 1 into factorial n minus 1. So in our factorial n, in denominator, value of the factorial 1 is 1, you know, into factorial n minus 1. Okay, then we expand it, and factorial n, we start from n1 less n minus 1. I am breaking here, so I apply factorial upon 1 into something something into factorial n minus 1. Cancel out factorial n minus 1, factorial n minus 1. The value of nc1 is comes to n. As like saying, if we want solve nc2, then formula factorial n upon factorial 2 into factorial n minus 2. I am opening it, factorial n, start from n 1 less n minus 1, 1 less n minus 2, applying factor, I am breaking here, so factorial n minus 2 into factorial 2, opening factorial 2, start 2 into 1 into factorial n minus 2, cancel out, so that value comes n into n minus 1 upon 2. You take a screenshot for making notes. Okay, then next formula n c n minus 1, applying combination formula factorial n upon factorial n minus 1 into factorial n minus r here n minus 1, so that will comes factorial n upon factorial n minus 1 into factorial n minus, that is cancel, minus minus plus factorial 1, so the value comes factorial n expanded n minus 1, and I am breaking here, so applying factorial upon factorial n minus 1 cancel out. So the value of n minus 1, that comes to n, as like same n when we solving it, applying the combination formula factorial n upon factorial r, factorial n upon factorial r, that is also n upon factorial n minus r, that is n. Then factorial n cancel out factorial n, 1 upon n minus n 0, that is factorial 0, and you know the value of the factorial 0 is 1, so value comes ncn is 1. Okay. Now uh, in first lecture we learn some identities. A plus b whole square, that is a square plus 2ab plus b square, as like a plus b whole cube, a cube plus 3 into a square b plus 3 into a b square plus b cube, as like a plus b whole power 4, a to the power 4 plus 4 into a to the power 3 b plus 6 into a square b square plus 4 into a b power cube plus b to the power 4. So if there are higher powers of a plus b, like x plus y, 1 plus x, something, if the higher power 5 and 8 or 10, a plus b whole to the power 10, then expansion of a plus b whole to the power 10 is very tough to memorize. A plus b, I say whole to the power 100, that is also tough. For solving that expansion, for opening that expansion, we required the original formula, and that is called binomial theorem. You see there, if power 2, if a plus b whole to the power 2, then in the expansion of a plus b whole square there are comes 3 term. If power 2, then there are comes in the expansion 3 term. If the power 3, then in the expansion of a plus b whole cube, then there will comes out 4 term, 1 2 3 4. If a plus b whole to the power 4, then there comes 1 2 3 4 5 terms. If, as like same here, a plus b whole to the power 10, then in the expansion of a plus b whole to the power 10 there are comes in the expansion 11 terms. Then there are comes 11 terms. In the expansion of a plus b whole to the power 100, there are comes, if power 100, then expansion 101 terms. As like same, if a plus b whole to the power 56, in the expansion of that there are comes 57 terms. As like same, a plus b whole to the power x, then there are come x plus 1 terms. As like same, if a plus b whole to the power x, then there are come x plus 1 terms. And second thing that if chalo as like same, if the power of a plus b whole to the power n, then there are comes n plus 1 terms. If whole to the power n, then there are comes n plus 1 terms. Second thing, you observe that in every term the power of uh, the uh, the power of every term, sum of the power is, if there are power 2, then in that term power becomes 2, 1 1 1 plus 1 2, b to the power 2. If there are power 3, in that term power 3, a square b to the power 1, then the sum of 2 plus 1 3, a to the power 1, 2 plus 1 3, there is 3, in a plus b whole to the power 4, a to the power 4, in that term 3 plus 1 4, 2 plus 2 4, 3 plus 1 4, and 4. Okay. Now what is the binomial theorem? Binomial theorem for a plus b whole to the power n, for you, as you wish, you put any value of n, 1 2 3 4 5 6 7 and so on, that comes n c 0, a to the power n, a to the power n, and b to the power 0, and the sum of power of a and b, it comes to n, a to the power n, b to the power 0, sum n plus 0, that comes n. After that, nc1, a to the power 1 less, n to 1 less, n minus 1, b to the power 1 increase 0 to 1, plus nc2, a to the power n minus 2, 1 less from n minus 1, n minus 2, b to the power 1 increase from 1 to 2, has like same nc3, a to the power 1 less from n minus 2, that comes n minus 3, 1 increase of the power b, b cube, plus nc4, a to the power 1 less, n minus 4, and b to the power 1 increase, that 4. And you see that everywhere the sum of power of a and b comes to n. In that term, power sum n plus 0 come n minus 1 plus 1 plus 1 minus 1 cancel, sum comes n. There is sum of n minus 2 and 2, minus 2 plus 2, that is cancel out, sum is out, n minus 2 plus 2, that comes n. Here n minus 3 plus 3 cancel out, sum comes to n. Here n minus 4 4 at n. Okay. As same that series going on, plus at last ncn, ncn 0 1 2 3 4, as like so on, n, a to the power n minus 1, n minus 2, n minus 3, that is decreasing and decrease to 0, and b to the power raised from 0 1 2 3 3 4 and so on till n. And there the previous term of ncn, a to the power 0, b to the power n, is n c n minus 1 a to the power 1 increase. When we go here in left side, power is increased, n minus 4, n minus 3. N minus 3 is greater than n minus 4 by the value of 1. N minus 1 is greater than n minus 2, so 1 increase a to the power 1, and power of b is going 1 less when we go through left side, b to the power 1 less n minus 1. When we solve it, you know a plus b whole to the power n is equal to nc0 is comes 1, a to the power n, a to the power n, and b to the power 0 is comes 1, and 1 into something something, so a to the power n plus nc1 that comes n. We solve sometimes ago. A to the power n minus 1, b to the power 1 is b, plus nc2 that comes n into n minus 1 into a to the power n minus 2 into b to the power 2, plus nc n minus 1 that comes factorial n upon factorial n minus 1 upon factorial n into n minus 1, factorial n upon factorial n minus 1 into factorial n minus 1 minus n cancel, minus minus plus, that comes factorial n upon factorial n minus 1, that is factorial 1, and when we solve factorial n, that n into n minus 1, applying here factorial upon factorial n minus 1 cancel out, so the value comes n. So the value of nc n minus 1, it comes to n, a to the power 1, b to the power n minus 1, plus ncn that comes 1, and a to the power 0 is 1, 1 into 1, 1 into b to the power n. That is the journal formula for my a plus b whole to the power n. As like same, if there is 1 plus x to the power n, so we solve it from nc0, but we replace a by 1, so we replace a by 1 by 1 by 1 by 1 by 1 by 1. We replace a by 1, and then a replaced by 1, 1 to the power n, 1 to the power n minus 1, 1 to the power n minus 2, 1 1. Here is the, and you take a screenshot. After that, a plus b whole to the power, sorry, we replace a by 1, 1 plus b whole to the power n, which comes to 1 to the power n, 1. You know 1 to the power 10 which come 1, 1 to the power 2 means 1 into 1, that comes 1, 1 to the power 100, that comes 1, 1 to the power n, that comes 1. Any power of 1 value becomes 1. So 1 plus n into 1 to the power n minus 1, that comes 1, and 1 into b 1 plus nb, as like same n into n minus 1, that value, any power of 1 value comes out 1, and 1 into something something v square, that series as like so going on, and that comes b to the power n into b to the power n minus 1 plus b to the power n. Okay, then if the value of the b is too small, if the value of b is too small, then we can neglect it, higher powers of b. If the value of b is too small, as like 0.002, 0.003, then the higher powers it becomes too small. Okay, and like same square of cube of 0.003, you operate it, the value becomes too small. 3 3s are 9, 0 0 0 1 2. Then the value comes that these value is too small. So if the value of b is like same, then we neglect higher powers because the value comes out too small. So we neglect higher power as like b square and b to the power n minus 1, b to the power n. So there is 1 plus b whole to the power n, that comes 1 plus nb, or 1 minus b to the power n, the formula comes out 1 minus n into b. That are the very important formula. We use these formulas in large scale in our physics in higher classes, so that are very important. 1 plus b whole to the power n is equal to 1 plus nb. 1 minus b whole to the power n is equal to 1 minus nb. If this formula, if the value of b is too small, is like same, if we 1 plus x to the power n, the value comes 1 plus nx, and 1 plus 1 minus x whole to the power n is comes out 1 minus x. that formula valid, these formulas are valid when the value of, if the value of x is too small. Okay, then we solve some questions. Then there are some questions. 1.0003 whole to the power 17. When you solve by your childhood method, that this question is very tough. So we solve it by binomial theorem. In binomial theorem, you want first term 1, so I expand it 1 plus 0.003 whole to the power 17, and then matching that is 1 plus x to the whole power n, and x is too small, so value comes out, I am applying 1 plus 17 into 0.000 into 3. Okay, then 1 plus 17 into something, multiplied it, okay, 17 into 0.003, and adding it 1.0051. That is the value of 1.003 whole to the power 17. That is not exact value, that is a approx value. And okay, then next question is 1001 whole to the power 1 by 3. That is the, okay, for simplicity we 1001 whole to the power 1 by 3, that comes out, when we expand it, 1000 plus 1 into whole to the power 1 by 3. I taking common 1000 into 1 plus 1 by 1000 into whole to the power 1 by 3, and the value comes out 1000 1 plus 0.001 whole to the power 1 by 3, and at this there, at there we applying binomial theorem, 1000 into 1 plus 1 by 3 into 0.001, and that comes you take a screenshot, that comes 1000 into 1 plus 0.00, carry 103. I stop here, and 1000 into 1.3, and when we multiply it, that comes 1000 into something, 1000.3. Okay dear, now we will meet in next class.